Hello everyone. In this video, I will be demonstrating how to blink an LED using STM32F446, and let us see how to blink an LED. So let's find out which LED is on the board. And I have opened the user manual. I have downloaded it from ST website. Now let me search ALD. It will be somewhere here. Yeah, here we go. There are three LEDs, and I am going to use the user LED, which is LD2. Now let us see with which pin is this associated. To do that, we need to download the schematics from ST website, and here I have found out the LED2. And when you trace this, you can find it is associated with the PA5. There are around, let me show you. Yeah, as you can see here, there are many ports. This is general purpose input output ports. Among these, the green LED is with the port A, and this is connected with the system bus, that is AHB1. Now, to blink an LED, we need to do three simple steps. That is, first we need to enable the clock for this GPIO port A. Then, after that, by using the mode selector register, we should make the PA5, that is the fifth pin of a PA, as an output pin. Then, after that, we need to manipulate the data in the data register of port A. By manipulating that, we can make the LED high or low and toggle the LED. Now let's get started. Go to the user or reference manual. Now let me show you the base address of the registers. Go to memory map, and you can see here GPIOA. Note down this base address. And the next thing is we need to note down the base address of RCC. I will show you what is RCC. Just note it down. Now, the next thing what we do is we will go to the, and we need the first thing we need to enable the clock. So let's find its register. Go to RCC registers, then find AHP1. Yeah, this is the register. As you can see, the offset address is 30. To find the address of this RCHB1, we need to add the offset address and the base address, which I have shown you earlier. Now, to set the GPIO-A, we need to set this high. So we are enabling the clock for GPIO-A. Now, let me show you. You can see here 04 clock disabled and 1 clock enabled. Now we have completed the first step. I will show you in the code also. I have created an pointer and given the address. This is the sum of both base address and the offset. Now I am enabling the clock. By this, I have used the left shift operator and the OR operator to set the bit. Now the next step is I need to select the mode. To select the mode, I need to find out the register. Let me find the register. To find that, go to GPIO. Here it is. Then GPIO register. Then the mode. As I shown you earlier, the base address plus offset address. Here the offset is 0, so there is no need to add. And here we have, as this is a 32-bit register, there are divided into 16 sections. Now we have to manipulate the data in PA5, that will be the 10 bit and 11 bit of this register. There are 2 bits, that means we have 4 modes, and we need to select the mode is the output mode. We need to write 1 to, we need to high the 10th bit and lower the 11th bit. First we will reset the both bits, and later we will set the 10th bit. You can see in code I have resetted both bits Now I am setting the 10th bit, and this will make sure that we have selected the mode output mode for PA5. Now we are in the last step. In the last step, what we'll be doing is we will be in a loop and continuously lowering and highing the pin 5, that is in GPIO port A5. To do that, we'll be using a system delay. This is not an hardware delay. This is a system delay. As let me show you, we have 180 megahertz. The ARM Cortex works on 80 megahertz, which is very high frequency. So you do a basic calculation to produce a 1 second delay. Let us assume that the need around 5 cycles to perform an empty for loop, and when we divide 180 megahertz by 5, we will get around 20 lakhs, I guess, around 20 lakhs, which is very high. But to produce a small delay, we'll be using 60,000, and it will be a decent delay, I guess. Let us see. Now, after this, what we'll be doing is, after producing the delay, now let us set the pin high. To do that, let me show you the register, and you can see here. Again, I'm going there, and I'll find out the data register. That will be the register where we need to manipulate the data. Let me find it. Yeah, this is it. As you can see here, 0 to 16, all are associated with each phonon pin. Now our pin is 5th pin, and we need to manipulate the data here. When we write 1, the output will be high, the LED will be on. When we write 0, the LED will be off. Now let's do that. Note down the offset address, and let's add it with the GPIO-A base address. Base address will be same for both the output data register and mode register. This is the initialization of pointer with the address of the data register, and here I have set the pin, that is the 5th bit, of the data register, and again I am producing delay. Now again I am clearing the pin, that is 5th bit of the data register. By doing this repeatedly, we'll be toggling the 5th bit. That means that we will be toggling the LED. And this was the code explanation. As you can see in this picture, PA5 is linked with the pin 11 on CN10. We can connect an external LED with the help of breadboard. We can blink an external LED along with an internal LD2, that is green LED. Now let's see the demonstration of the actual circuit. This is the demonstration of LED blink using STM32F446. Here it is a very simple circuit. I have just taken the ground from the STM32 board and given it to the negative terminal of LED, and I have taken the pin 6 from STM32 and given to the positive terminal. As you can see, both the green LED on the board and on breadboard both are blinking. This was the demonstration of this video, and I hope you understood. Thank you for watching.